Yes, ma'am.
Shall we start?
Sure, ma'am. Sure.
Yeah, okay. And parallelly, we are streaming this in our YouTube channel so that all our UG students are joining there, ma'am. Gayatri, ma'am.
Sure.
This is
Sure,
for your
ma'am. Sure. Okay.
Not
Yeah.
only the UG students and these students are joining over here in this group,
Okay.
engineering
Yes,
and
ma'am.
UTL. Okay, ma'am.
Sure.
Rest are joining in the YouTube stream. Okay, please just
Sure. Okay, ma'am.
welcome and good morning, one and all present over here. I take this propose to welcome Dr. K.S. Gayatri, Assistant Professor in the Department of Information Technology, SSN College of Engineering, today's speaker. As an introduction, Dr. K.S. Gayatri ma'am is an assistant professor in the Department of Information Technology, SSN College of Engineering, over 2 decades of experience. She has earned her PhD degree from Anna University in 2018 in the thesis titled as Activity Recognition in Smart Home. Her research focuses on providing ambient intelligent solutions for smart environment. She is a recognized supervisor in Anna University and her research interests are artificial intelligence and machine learning. She has published around 18 research papers in reputed international journals and conferences. One of her research publications in Elsewhere Journal has received a certificate of application for high impact factor journal publication from Anna University in 2018. She is an active reviewer in various international journals such as IEEE Transactions, Elsewhere, and Springer. She is a doctoral committee member in various universities. She has also guided several projects and organized workshops related to artificial intelligence. Very proud to have you in our midst, ma'am, and
Thank you,
thank you
ma'am.
for accepting our invitation. Now the
Thank you.
session is yours, ma'am.
Thank you so much, ma'am. Okay. So, am I audible?
Yes, ma'am, you're audible.
You're audible. So, good morning to one and all. It's a privilege and honor to be a part of your induction program. Uh, so, so I just went over the brochure of this induction program. I saw most of the topics that are dealt in the induction program are is something which is very general. Okay, so my topic, which I've taken up here, is application of AI in the design of self-driving car, so or the autonomous vehicle. Okay, so I will just justify why did I give this particular topic in the induction program. So since all of you in the first year of your engineering or arts or whatever in your degree program, it is essential that each one of you have an intention that you have to solve some real world problem, okay, with whatever concepts you've studied in your course. Either it's going to be an engineering stream or whether it's going to be whatever bachelor degree you're going to do. So whatever concepts you study, ultimate thing, the final vision should be to deploy or employ those concepts to some real world application. Okay, so you can look at my title. There are two parts in the title. One is an application of AI. AI is the most happening technology right now, so it's something which you will study in your curriculum or a course. And the second half you can see is a most, each one of us are very familiar with what is meant by a car, and each of us are keen to know about what is an autonomous vehicle or a self-driving car. Okay, so I'm going to give you just an overview of how these concepts that you will be studying in your curriculum and applying it to some real world problem. Okay, so that is why I have chosen this particular topic, because when you are in the first semester or in the initial part of the UG degree, you should have an interest of doing some projects, okay, and understanding the depth of whatever you are studying so that you can deploy it into any real world problem. Okay, so this will be not going to go much into very technical details of solving these problems, but I'm going to give you an overview of how an AI is playing a vital role in one of the problem like self-driving car. Okay, so my title was actually called as autonomous vehicle. Okay, autonomous vehicle could also be called as a self-driving car, or you can even call it as a driverless car. Okay, so most of you know what is meant by sensors. Okay, so your smartphones has got sensors, and all over you have some video cameras fixed. Okay, and everywhere you have GPS. Okay, so all these small miniature what devices are actually called as sensors, which get some information about us. These sensors have developed very high, as well as these AI techniques, artificial intelligence techniques also have come as developed in such a way that you can integrate these sensors and artificial intelligence technology together to build this self-driving car. Okay, so what exactly the self-driving car is, we have to drive a vehicle or a car in such a way that you reach your destination, and when you drive your car, it is that human intervention should be minimum. Okay, so without a human operator, the vehicle should drive itself to the destination. So that is the objective of the self-driving car. It's a very general problem. Anybody could understand what is meant by an autonomous vehicle, or um, a self-driving car, or whatever it is. Okay, but the question is, why should we build these autonomous vehicles? Already said there are so many vehicles on the road, and most of us are comfortable in driving any vehicle, whether it's car or whatever it is. But what is the need? Okay, what is the necessity to build these autonomous vehicles? Okay, now in urban places, you can see there are a lot of congestion, traffics, fatal rates are increasing, and the driver feels so stressed, because if there is there was an outbreak in rain last week. You can see how it was, what the entire Chennai city got stuck. Okay, so these are something, and the driver feels so stressed sitting in one single place, driving without driving, and got caught into a traffic or whatever it is. Now, the need for these autonomical vehicle is that it makes the driving more systematic, and it reduces your traffic congestion, and naturally it reduces the stress on the driver, and then it reduces the fatal rate. And you can see these statistics tells you that when we are going to model and all our vehicles in the road are going to be an autonomous vehicle, there is a probability, or there is a percentage, that the safety, the driver stress, the fatal rates, the congestion, all that is going to get reduced in so many percentages. Okay, so it's not just for fun we are building these autonomous vehicles. So there's some purpose or some need for which these autonomous vehicles could be built. Okay, um, this autonomous vehicle, now it's a very buzzword. Everybody is speaking about self-driving car. Everybody is speaking about autonomous vehicle. It is not something that is jumped into 2020. Like everybody are talking about these autonomous vehicle. So it has evolved over a period of time. In 1990, before 1990s, people started developing like something, a very simple thing like an anti-lock brakes, which you have in a vehicle, and later they gradually introduced these intelligent parking system. Then they brought in the adaptive cruise control. Okay, lane, you have to keep your lanes. Okay, they brought in these systems into play, and later they brought into some automatic valet parking. So it was a gradual progress. Okay, they started building small modules in such a way that in 2020 right now we are into modeling, building a full autonomous vehicle. Okay, um, when I say autonomous vehicle, it is, I'm planning to build a car which will drive on a road without a driver. That is the intention. Okay, it is not that easy to build a system where you don't have an human intervention, because there could be a lot of uncertainty when you drive a car on the road without a human vehicle. So there could be an obstacle. So there could be a cow crossing the road. Okay, so there could be there could have been some hollow in the road. It's not that easy to build an autonomous vehicle which is fully automated. Okay, at one step you can't build such a self-driving car. Okay, so what these a society of automotive engineers, they have given different levels of autonomy. Okay, so what they've done, they've brought a scale from 0 to 5, telling 0 is a scale telling no autonomy, automation, and the level 1 tells you that these automation is to provide some assistance to the driver, telling him that you're going out of the lane, come into the lane, or it is guiding them to apply brakes, something. So it's only for a driver assistance. Okay, so at the level 2 you can see there are partial autonomy, and third one is like conditional autonomy. Suppose you're driving in a highway, so probably there you can become autonomous. But when you come into a congested city, probably a driver can take up. So this, it's like a conditional autonomy. And fourth level is little more higher than the conditional autonomy, and fifth level is going to be the full autonomy. Building a system, okay, which is going to be fully automation or a fully autonomous vehicle is not a very easy task. But because through my presentation you can see there are so many aspects that we have to look at in design of self-driving car. Okay, and this statistics tells you the forecasting on when we will achieve these level 3 autonomy, level 4 autonomy, and level 5 autonomy. So it has been told around 2035 we will reach 80% of autonomy, and by 2040 probably we will have the level 4 autonomy, and then by 2045 we will have the full-fledged of level 5 autonomy. Okay, so right now we have just started in gradually into the L3, L4, and L5, but there is no system as such which is completely autonomic. Even your Tesla, your Waymo, whatever self-driving car you have in the market, okay, so they are not completely autonomous. They are at the level of L3 and L4. Yes, okay. So this is a picture that tells you every automotive industry have started investing their money and energy into these automotive vehicles, because it's a people have there are so many challenges, that DARPA challenges which have been organized to build the self-driving car. And you can see in 2018 Waymo is actually a Google's self-driving car. Tesla has started, okay, developing these in addition to the electrical vehicles, they started even building these autonomous vehicles. You can see each of the car or the automotive companies which you know have started investing their energy and as well as their money into developing these self-driving cars. So it's the most happening field, that designing a self-driving car is you can expect to have vehicles which is completely autonomous down the lane. Okay, so this is about an introduction about your self-driving car. Okay, we know what are we. This is the problem that we're going to solve. We want to design a car which is completely automated. But I can't do it as such because we require the help of some technology or concepts that will take over charge of building these systems. Okay, so artificial intelligence is one of the most happening and what the most important computational technology right now. Any stream you're in, whether you're going to be in a mechanical engineer, or you're going to be a computer science engineer, or you're going to be in the arts, finance, commerce, or whatever it is, you can see some way or the other these artificial intelligence techniques, data analytics, data sciences have taken over. Okay, you cannot imagine any field of what any field or any application domain where you don't without an artificial intelligence. So it is actually playing a very very vital role in all the problem solving aspects. Okay, so what is a very simple definition of these artificial intelligence? Artificial intelligence is making a system or a robo or a computer to think like and act like a human. Okay, so you can see these two words are very important. You have to think like you should have some common sense reasoning like a human. You should have what a decision making capacity like a human being. In addition to that, you should also execute those whatever you're thinking into action. Okay, so these we are making a system or a computer to think and act like a human. So that is the you can say a very abstract definition of an artificial intelligence. Okay, so there are different aspects in which these artificial intelligence are actually looking at. So one is called the big data analytics. The other one, we have machine learning, deep learning, which is this part, your learning part. And then you have reasoning, you have problem solving skills. Okay, so problem solving skills is one of the main aspect of this artificial intelligence, why it has become so vital in a day-to-day life. So because even your self-driving car is one of the problem solving aspect, it is one of the complex problem that we are trying to solve. In order to solve it, we are taking the help of the artificial intelligence techniques in order to address a lot of challenges in the design of self-driving car. Okay, what is this big data analytics? So we have video cameras fixed all around us. Most of us know for surveillance purposes these video cameras are fixed. You can imagine the amount of data it is populating at every fraction of second. So the data is actually very difficult to handle, very huge massive amount of data as we have. So these algorithms, these artificial intelligence techniques should provide you a strategic way to handle these massive data. And you can see there's something called structured and unstructured data, where structured data are very easy to model. But right now, since you have video data, since you have speech data, and then you have blogs and other things, which is very highly unstructured. Even coming out with strategies to handle these unstructured data are very challenging. So this big data analytics is one of the main focus of this AI, because of which it is actually more trending today. Okay, and the other very important aspect of this AI is learning from the past. One of the important characteristics of the human is that he learns out of his experience. Okay, nobody can replace the experience. So if you have invested some 2 months of your time in developing a project, you might not be successful in coming out with the output of the project, but the experience that you gain in the 2 months in solving the or building that project is something which will help you out in building something else. Okay, so the experience is very important. And these machine learning algorithms or the deep learning algorithms are one set of algorithms on AI which helps you to model this aspect of learning from the experience. Okay, and another aspect of AI is that the reasoning part, when you have what when you're trying to solve a problem, you have to be very situation specific. I cannot apply the same type of solution for different situations. Okay, so you call it as context. Okay, different context for different situations, I have to come out with different way to solve the problem. So that is also a very important aspect of a human being, which we are able to simulate using these artificial intelligence algorithms. Okay, so these four categories are some four aspects of set of algorithms that your AI contains to model any real world problem.
Ma'am,
Okay,
sorry for interpreting, ma'am.
yeah,
Are you sharing your screen, ma'am? Actually, your screen is not visible.
really, ma'am. So
Yeah,
okay.
yeah, you haven't shared your screen.
Oh, sorry, ma'am. Till now, from the starting.
No, from the starting, you haven't shared.
Oh, really? I'm sorry, ma'am.
No, no
Oh,
issues, ma'am. No issues, ma'am.
okay. Now is it visible, ma'am?
Yes, ma'am, it is visible. Maybe you need, yeah, ma'am. It's perfect.
Okay.
Perfect.
I'm very sorry about it.
No, no problem, ma'am.
Okay, so this is what I've actually discussed. What is a self-driving car? Okay, and what are the benefits of these autonomous vehicles? Okay, so this shows you the percentage of why we have to have an autonomous vehicle, and this tells you the evolution. Okay, on how these autonomous vehicle have come into play. And there are 5 levels of autonomy, which the Society of Automotive Engineers have come into, and this is the full autonomy. So the ultimate aim is to build a self-driving car with the level 5 of autonomy, and this is the forecast of when do we achieve this particular autonomy. Okay, and this is the timeline diagram showing different engineering organizations have invested their resources in building a self-driving car. And this is what I was just telling you about what is an AI approach. And these are the four aspects of AI, where you say a big data analytics, reasoning and learning and problem solving are four different aspects of artificial intelligence. Yes, am I clear up to this? So this is my screen still visible? I'm just clarifying it before I proceed. Ma'am, is my screen still visible?
Yes, ma'am. Your screen is
Yeah.
visible. Yeah,
So,
everything is
yeah,
perfect. It's
perfect.
going on.
Okay. Okay. So there's a buzzword like artificial intelligence. It has actually started in 1950s, and you can see these artificial intelligence techniques, these machine learning and deep learnings, are just a subset of this AI techniques, and all these problem-solving aspects have become more successful after these set of algorithms like machine learning and deep learning when it came into play. Okay, I'm not going to go deep dive into all this. Just an overview. At least these terms you have to understand, because all of us have what a responsibility in solving a lot of complex problems using these AI techniques. The general difference between a machine learning and deep learning algorithms are such, like when I have a problem, machine learning algorithms does a lot of you have to do these feature extractions first, and then you have to build these machine learning models. Whereas in a deep learning model, this feature engineering or this aspect is actually not required. Automatically you can build your machine learning model, deep learning models to produce an output. So I'm not going to get into this part because you're too what in the first semester to go deep dive into all this. Okay, so now we'll come now. You know what is AI? AI is to make a system to think and act like a human. And you know what is a self-driving car? The ultimate aim is to build a vehicle where you will drive a car without a driver. So these are two different aspects. How do I integrate AI into this autonomous vehicle? Okay, so any AI system whether it's an autonomous car or any intelligent system, follows this particular life cycle where I sense the environment. I sense in the sense, like a human being, you have to perceive. You use your eyes, you use your ears to observe what is happening around you. So similarly, any autonomous vehicle should have some sensors which will observe what is happening around the system, and then whatever you see, your brain processes it. So you require some kind of an understanding or some computational reasoning, okay, that is happening with whatever you perceived. And then with whatever you perceived, you have to perform an action. Suppose I keep my hand on a hot kettle, then my reflex action, I put away my hand. So this is the action that I do for the sensory information that I've got. Okay, similarly, your autonomous vehicle should also perform some action. Okay, so you can see in an autonomous vehicle we could have sensors like cameras, radars, lidars, and so on. Then we combine all these information, you do some kind of a computation, and then you decide whether I have to apply a brake, or whether I have to do some turn my steering, or whether I have to accelerate more. Okay, so these actions I decide in the way I sense the information and understand and perform an action. Okay, how does a self-driving car work? Okay, so now you have a car, all of us know what is a car, but there's no driver inside the car. So there should be some sensors which are fixed on the in the vehicle, so that the car is able to perceive in the sense able to observe what is happening around the vehicle, probably who's standing before me, whether I have a traffic signal, whether I have a zebra crossing, whether there's another vehicle moving. Okay, so all these information has to be captured. Okay, so how do I do it? You can use video cameras. That's the most common sensor that you can use for perceiving the environment, but it is not sufficient. We'll see why it is not sufficient to observe the environment. So that is why most of the self-driving car uses lidars, okay, laser sensors. They use radar sensors, they use GPS, they use ultrasonic sensors, they use IMUs. So there are about 5 to 6 sensors that are fixed on various points of your car to observe different informations from the environment. Okay, so this is a need. So as a human, since we have sensory organs, your vehicle should also have sensors to observe what is happening around the environment. Okay, so first, sensor. So just we'll have an overview on what types of sensors we can use, a justification of why these sensors are required. Okay, cameras are video cameras. All of us know what is meant by video cameras. Video cameras are fixed on the front, back, rear, and left side of the vehicle. Okay, why these cameras are required? Probably these cameras gives you a picture like this about your zebra crossing, about who's crossing the road, whether I have a vehicle's here. Okay, a complete information about your surroundings could be captured through a video camera. Okay, so this is a very fundamental sensor that you have to fix on the vehicle. Okay, but the issue is, when I use the cameras will tell you that whether there's a person here, but the vehicle will not be able to find out how far is this person from my autonomous vehicle. Probably the distance between the object I mean the person, okay, to the vehicle. Those informations are not captured in cameras. Okay, the distance information is not available. And cameras are good when the climatic conditions are very clear. In the morning situations, your camera might give you a better clarity in the information that it's capturing. But in the low visibility condition, or during rainy season, or during night time, the information that you capture in the cameras might not be that useful to decide whether I have to apply my brake or whether I have to move forward. Okay, so I'm not able to decide because the information that your cameras are providing are not sufficient. Okay, so because of these drawback, the next type of sensors came into play, which is called lidars. Lidars are the most important what sensors with which self-driving cars are being developed. Okay, so this is called a light detection and ranging. This sensor is a bit costlier when compared to the rest of the other sensors. It uses a laser technology. What fundamentally does is, these lidars which are fixed on your cars radiates lasers light. Okay, you can see it sends out these lasers lights around. If this is going to be an autonomous vehicle, the red circle is with this autonomous vehicle. It radiates laser lights in all 360 degrees around it. Now, what happens is these lidar informations are converted into a 3D cloud. 3D cloud. This is actually a 3D cloud information. What happens is this lidar technology is so prevalent that it is able to tell you the shape of the object which is around you. It is also able to tell you the distance at which that object is placed from the autonomous vehicle. It does not worry whether it is going to be a morning or a night situation or rainy. Whatever climatic conditions, you can radiate these laser lights and you will be able to capture what is around it. Okay, so that is why lidars are actually what very important in the design of these self-driving cars. Okay, but the thing is, these lidars, one of the limitation of these lidar sensors is that it is not able to tell you at how fast is the other vehicles around you are moving. Okay, so dynamic objects, like there is some car going beside you, you are not able to capture how fast is that car beside you is actually traveling. Okay, so that is one of the drawback of these lidars, because of which these radars actually came into play. Radar's expansion is radio detection and ranging sensor. Okay, so these radio detection ranging sensors, this actually radiates the radar waves. One of the advantages is this radar wave can that it can travel to a longer distances when compared to the lidar. Lidar has got a limitation that it can perceive information only through a certain limit. Okay, but these radars, if it is going to be a long distance objects that you want to track, probably these radars will be helpful. Okay, and one of the additional advantage of these radars is this radar is able to tell you how fast is the other vehicle traveling. Okay, which is also very important information that is required for me to travel safely. Okay, so I should travel in such a way that I should not collide with the other vehicles. That's one of the objective. Okay, so these radars will tell you how far these other vehicles around you or the moving objects are moving. So that information also could be used through these sensors. Okay, you are able to get these sensors. So GPS, all of us are familiar with the GPS sensors. Your smartphone contains GPS sensors. It gives you the latitude and longitude value of where exactly you are in the location. This information is actually required, okay, for a self-driving car, because with the current location, you will know whether I have any static objects around it, whether I have a traffic signal, or whether I have a speed breaker or something like that. Okay, so in GPS are essential to provide you the local information of the current state or the current position of these cars in the environment with respect to the environment. You can see from the figure, you have to know where this car is with respect to this entire environment, because depending on that only you can make your car to progress forward. But people who are designing a self-driving car are not too relying on this global positioning system, because there's a delay in the information that you gather. Okay, so the literature survey tells that the GPS coordinates that you get, there is some 10 meter, like there is some difference in terms of some 10 seconds or something. Okay, so there's a lapse in the information. Even such small lapse can lead to some disastrous accidents in the case of the design of these autonomous vehicles. Okay, so that is why, in addition to this GPS, they don't completely believe in the GPS information. The other informations like lidars and radars informations are taken together in addition to the global positioning system to find out what location the vehicle is. Okay, so the other type of sensors that you can fix on the car is your inertial measurement unit. This is another very simple a sensor which is fixed in the car on the lower on the base side. So the objective of this sensor is that it gives you the position of the car, whether your steering wheels are straight, or maybe your wheels are in straight direction. At what angle is your at what angle is it inclined? Okay, at what height are you in the car? Okay, all these informations be captured by using these inertial measurement unit. Okay, so probably this is something that I've not gone into the topic of designing an autonomous vehicle, but you can see from this diagram or the figure, sensor, like a human being, since we have eyes and ears which gives you a complete information, we are able to turn our heads and capture so many informations. Your car should have, your vehicle should have sensors to capture all the information like what a human being perceives. That is why you can see cameras, radars, lidars, sonars, GPS, IMU, all these sensors informations are taken together and given to the first module in the design called perception. Okay, so what fundamentally we need to do here is, we have to take these sensor inputs. Okay, do some perception in the sense I have to find out what is the vehicle around me, whether do I have a speed breaker, do I have a traffic signal. So all these information should be perceived depending on your perception. Okay, depending upon what you've understood from these sensors, you have to do some planning. Or what type of control should I do? Should I change my steering angle? Should I apply my brakes? At what speed should I travel? Okay, so all this planning will happen with whatever information you have perceived. Okay, so you can see from the sensor data, we do some perception. Then I tell you what is prediction, what is planning, and then finally you get into how, what action I should do. Okay. So in addition to these sensors, there is one common information that all these modules, your perception, your planning, your prediction, all these are all actually called some modules in the design of the self-driving car. All these modules of perception, prediction, planning, and simulation require something called HT maps. Okay, HT maps are nothing but high definition maps. Okay, you can see without these high definition maps, these modules of perception, prediction, and planning can never execute. Okay, so then what is this high definition map? Why is it actually play a very, very vital role in the design of self-driving car? Okay, so these high definition maps are nothing but it is a map about your surroundings. Suppose I say if I'm in Chennai Mount Road, you have to know what buildings are there in that particular road. Okay, in that particular road, where how many lanes do you have the road? Okay, and where are the traffic signals placed in the road, and where are the speed breakers, and where are the zebra crossing. These are some static information which is never going to change for a long period. Okay, probably for 5 years, there might not be much change in these static information. So these static informations might not be captured through the sensors, because sensors have got a limitation of how much it can capture. So these static information, since it is not going to evolve or not going to change over time, these HD maps are is providing you an additional information about the environment, telling you about the static objects. Okay, so it's like you can take it like a Google map. Google map tells you the roadway connecting between two locations. Okay, so these HD maps are not Google maps, but these are maps which is telling you about the static objects in your surroundings. Okay, so here you can see this is an example of how a HD map looks. So HD map tells you where you have a traffic light, where do you have a crosswalk, where do you have a stop lane, where do you have a wall, where do you have a barrier. Okay, all these informations are provided in the HD map. Okay, why is this HD map so important? Yes, probably if your autonomous vehicle is driving down the lane, it can hit a wall if you're not able to perceive this particular wall. Okay, if the traffic light gives you a red signal, and if you do not know that the traffic light here, probably you might hit another vehicle. Okay, so these static informations about your surroundings are very, very important for a smooth, the objective on the design of a self-driving car is to have a smooth safe driving to your destination. Okay, so these informations help you to have a smooth and safe driving. Okay, and so as I mentioned, it tells you these HD maps are very, very important because you cannot make a car to drive by itself without all these static informations. Okay, okay. How do I construct this HD map? It's not like a Google map. You use a Google API into your code, and then I get those information, and I'm able to model it. Okay, there are some open HD maps available for some US countries, US cities, but there is no such HD map available for the Indian context or to some specific cities of Indian countries. Okay, so then we have an important role of designing these HD maps. How do I design these HD maps? Is that you assume that I have a car, I have these radars and radars fixed on it. I drive that particular car where I allow the radars and radars to capture all the information about the surrounding. I capture the data, that is called as data sourcing. I capture it. This I'm telling you, before you deploy a car, before you make an autonomous car to drive itself, my first job is to construct an HD map. How do I construct it? Fix all the sensors in the car, make the car to drive, capture all the information, process this data. Okay, so like the point cloud registration is your LIDAR data. You process the data, then use a machine learning or deep learning algorithm to classify the objects. There are some most happening object detection algorithms in deep learning. You can employ those algorithms and you can tag each of your objects, like this is a traffic light, this is going to be a wall, this is going to be a crosswalk or something. You can do an object detection. Then your system is actually doing that for you. You label those informations. Then you're doing a manual verification whether it is going to be a crossroad or whatever it is. And then you have, once that is manually cross verified, your HD map is available for you, telling about the static information about the surroundings. Okay, so your input. So now as we write programs, we say input. What is the input to the program? What is the output to the program? As of now, we have just spoken about the input to the program. Input to the program is the information that you perceive, that is your sensors, your LiDARs, your radar information, and then your HD maps are some information that you give as an input to the self-driving car system. Okay. Now, once I get this information, I have to do a kind of reasoning or computation or understanding whatever you received. The first understanding that I'm going to do is called where am I? Okay. This is a self-driving car. I have to decide where I am in this environment. Suppose this is a self-driving car. First, before I decide whether I have to accelerate or whether I have to apply a brake, I have to first localize my information, understanding in this. Yes. Oh, sorry. Okay. So I have to localize and find out where I am belonging to the environment. So in which particular lane I am in, or what is the surrounding what information that I have. So this information should be captured. Okay, this is very, very important before I decide what exactly I have. Okay. Any doubts till this? Am I clear in whatever I'm conveying? Any clarifications? Yes.
Ma'am, you are
Or
clear, ma'am.
yeah. Okay.
Yours is
Fine.
going clear.
Yeah. Fine.
Any
Thank you.
doubts?
See, I'm
No,
not,
madam.
no. So I'm not telling you much into the technical. I'm just telling you, you can visualize a car and see your plan. You think of like you're building a autonomous vehicle, what exactly is required. Okay. So we think it's very easy, but there are small aspects that we have to focus on. So that is the objective. If I'm not clear at any point, you can stop me at any point of time so that I can update with the information, which you can will be very helpful for you. Okay. So with the sensor information, so first thing I have to do is what? I have to localize myself, finding out where I am in this particular environment. So that technically in the design of self-driving car, it has called localization. Okay, localization is nothing with the sensor. You have LiDAR, all these sensors, it is giving you all these information. What you need to do is we have to localize and find out where exactly I am in this environment. Okay, I can do this localization only if I detect the object, as well as I require these HD maps. With these sensors information and the HD maps, nothing but your surrounding information, I will be able to find out currently where I am in. Okay, that's the first. Yes. So this localization, there are different aspects of localization that you can actually focus on. One way, the easiest way is to find out where exactly a self-driving car is using a satellite-based localization. So which is nothing but your GPS. The GPS tells you exactly the coordinates, current location of the car. That is one way of performing localization. As I mentioned, GPS is not reliable. Okay, the reason is there's a delay in communication from the satellite. Okay, which where a fraction of delay also might lead to some disastrous effects. So you completely don't completely rely, but you can partially take an information from the GPS. Okay, the other way of doing this localization is using a relative mapping. In the sense, already you have static map given to you, that is your HD map. You can find out how far I am from this particular building, how far I am to this particular traffic signal. So I can do a relative, I will find out the relative displacement from static objects in the environment to exactly find out my current location. Okay, so there are some set of algorithms which you can model the localization using that aspect, or you can use a feature-based localizations. These are some machine learning techniques which could be used for the localization. The other way is I can find out my relative displacement. I know my previous time period where I am, my current time period where my vehicle is, how much far I have displaced depending upon the acceleration. You can kind of find out where exactly I am in the environment. Okay, so this localization is actually very, very important, because once you localize, then only I can decide what and how I can plan what should I do in the next sequence. Okay, so these are some of the technical terms. There are a lot of Kalman filters is the most commonly used localization and technique. Particle filters. There are something called SLAM, simultaneous localization and mapping algorithms. There are different set of SLAM algorithms, Kalman filters and particle filters, which exactly does this understanding of where I am in the current environment. Okay, your first step is over. The second step is that I have to look at, I know currently if this is my autonomous vehicle, I know where I am in the environment, but that is not sufficient. You look at this picture, you can see there are so many things around me. If I have to drive my car, I have to find out what are the other vehicles on the road, in which lane they are in. Okay, whether I have a traffic signal, whether there's a tree beside me. Okay, all the additional informations about my surroundings are very, very important for my smooth driving. My, in the sense, from the autonomous driving. Okay, so the second step in the design of these autonomous vehicle is that after you find where I am in, I have to find out who's around me. Okay, that is very important. uh, so there are some set of algorithms called object detection algorithms in machine learning and deep learning, where these algorithms, when you give these inputs of your cameras, your lidars, your radar, when you give and the HT map, when you give all these information as an input to this algorithm, that algorithm will be able to tag. You can see this tagging in the sense, this bounding box. All of you know what is a bounding box. You put a bounding box, it tells you this is a car. The probability of this to be a car is 0.99. The probability this is a bicycle and a person riding on it is going to be so much percentage. So this algorithm, what it does, when you give these inputs to this algorithm, it's one of the algorithm in the machine learning or a deep learning technique, where it is able to classify what are the different objects which is around you. Okay, so this is a second component that an autonomous vehicle should focus on, identifying who is around me. The other vehicles are called as agents, and my vehicle, I call it as an ego vehicle or the autonomous vehicle. Okay, so the second step is to identify what objects or what agents are around me. You can see this example is a snapshot of some output of a project, where it is able to find out how many vehicles you have, how many road signs you have, how many persons you have surrounding you, and how many traffic light signals you have in the scene. Or this is called as a scene of a particular current situation. Okay, once, how do you do it? I extract it, give it to a machine learning algorithm, give this input to the machine learning algorithm, extract the features and give it, perform a classification, tag it as a person or a bicycle. Or your deep learning algorithm will automatically looks at the feature extractions and classifies it to be a person or a vehicle or a traffic signal and so on. Okay, and this diagram tells you that can use a lot of other sophisticated deep learning algorithms for different what high level objectives of pixel classification, object recognition, and so on. Okay, so there are two steps have been done. I've got some information through the sensors. With the sensor information, I found out where I am in the environment. So this is what I mean, where I am in. And also I found out who are around me. So I've identified there are so many vehicles around me. This is the lane and all. The third step is I should also find out what are the other cars around me will do in the next time period, for the next second. In addition to what I should do, I should also find out what the other vehicles will do. Whether the other vehicles is going to stop and park their car, or the other vehicle is going to take a right turn, or the car behind me is going to hit me, or whether the car beside me is going to take a left turn. Okay, I should also observe, or I should also predict and calculate what the other agents around me should do. Okay, so this information is called motion prediction. Okay, this motion prediction is nothing but looking at the other vehicles around me and finding out what the vehicles will do so that my journey or my action will be safe by taking in the other agent's calculation into consideration. Okay, why should I do it? So this is called motion prediction or motion planning. What exactly you do? If this is the autonomous vehicle is going to be this car. Okay, probably this blue vehicle is an autonomous vehicle. This is another car which is there in the environment. Okay, this car, when it is in this position, this agent can either move straight or it can move. It can take a right turn. Okay, so this information is very essential because if this vehicle is going to move straight, the autonomous vehicle might hit on it or they can have an accident. Okay, so you should know at what pace or what speed is this car moving. That's the first thing you have to understand, as well as you should also know whether you have to forecast, okay, or whether you have, that is called prediction. What will happen in future, you have to find out whether this vehicle might take a race straight path or whether it's going to take a left turn. That has to be understood so that my journey I can plan an action accordingly. If this agent is going to move straight, I cannot control the agent, but I can control my action where I can apply a brake and pause for a while before I move forward. Okay, so motion planning is a very, very essential component of a self-driving car, finding out what the other vehicles around you is planning to do. Okay, how do I build this motion prediction? Take the sensor information, take the maps. You have a neural network. This is your deep learning model. There are already you placed a camera and a radar and you observed the pattern in a city. Okay, daily how your vehicle moves, how people are applying brake, and all those informations are captured. And with that captured information, you've done a modeling, and that model could be used for your motion prediction. It's a challenging task, but there are lots of deep learning algorithms that have come and focused on this motion prediction. They've used efficient net, ResNet architectures to build these models. It looks simple, but it's actually most challenging task because you have to look at other cars, how is it moving, a bicycle, how is it moving. All these recorded information of the past history are taken, and then a deep learning models are being used to deploy to build this machine learning model. Huge research is actually happening in motion prediction. This in itself is actually a very, very vast area. It looks very simple. This is a very big research area where a lot of efficient algorithms, sensor fusions, and all that is happening to build these motion prediction models. Okay, a lot of deep learning algorithms are being used for your CNN, RNN, and AE. Okay, people who are interested can look at a lot of study. There's a lot of literature, surveys, and projects available in the deep learning in this aspect. A lot of deep learning algorithms are being used for different purposes of motion planning. Okay, once I found out where I am in, who's around me, what those agents are planning to do, the next step is what should I do? Okay, what should I do in the sense, what should the autonomous vehicle should do? Okay, so what should I do is that, should I keep the same lane, or should I change my lane to the left lane, or should I go to the right lane, or should I apply a brake, or should I accelerate much faster? Okay, so these are some actions. So now you have done a lot of understanding on the data that you've taken. The next step is your action. So we said AI's definition is what? Thinking like a human and acting like a human. Now this autonomous vehicle is your AI system. Now that system should decide what should I do right now. Okay, so in order to do that, first step, a car, you know your destination, where it has to go. All of us know what is a Google map. You know, before you start traveling, you give your destination. That the Google map is giving you the shortest path to reach your destination. Okay, this route planning is something similar to that. Before you start your autonomous vehicle, you have to do this route planning. Okay, so the autonomous vehicle will have something like a Google map or some shortest path algorithm, which takes in different context in the situation and comes out with the shortest path to move from the starting point to the destination. Okay, so you have a complete route, the overall route, in the roadway should I travel to reach my destination. Okay, that is clear. In addition to that, now every fraction of second, I have this information given by radar. Every fraction of second, I've been populated with that information. Okay, what your system is doing, it is finding out where the vehicle is in that particular second, where who's around me, and what the other agents are planning to do. With that information and this route planning, that is called a global plan. Global plan is what is the overall path will I take, or will my vehicle ride to reach the destination. With a global plan, I have to make local plan. Local plan, suppose there is some heavy traffic in one particular road and there is some congestion, I can take a different route. Okay, that you can term it as a local plan. Or if there is a traffic light going to red, I should stop there in the what stop line. I should stop my vehicle. So those are something, a local plan that you have to make in order to make your global plan. So this is called as a behavior layer, where you take in a lot of, so you take in your sensor information, you take this localization information, all this together, you decide what local action should I do. So that local action tells you whether I have to keep on the straight same lane, or whether I have to do a left turn or right turn, or whether I have to take a U-turn. Okay, all that could be defined by in this behavior layer, which is actually your local plan. Okay, so in order to make a local plan, it's not that easy to do a local plan or a decision making, because you can see there are some 7 layers of information that I have to process. What is the road layer? Do I have 2 lanes, or where I have 3 lanes? What is the traffic information in the current lane? And what speed should I ride in this particular road? Should I go cross a speed limit of 100 in this particular what an urban road? Okay, what are the different connections you have? Do you have a U-turn, or what is a lane layer? Okay, and this map tells you where do I have a traffic signal, and a sixth layer tells you that what is the dynamic change in the traffic signal, or whether I have a pedestrian crossing where people are crossing on the road. So these are some dynamic informations. All these information should be combined. Each of these layers, there are some analysis that you have to do, combine it together to decide what action exactly I'm going to do. Okay, so once you've calculated that, now I can decide whether I have to take a curve. Even here, you have multiple ways to take an action. I should ride a car so that I don't have steep curves or something. There's something called trajectory prediction. So I should this is one aspect where I should make my car to have a smooth ride rather than making a sharp steep curve which makes the person inside uncomfortable. Okay, so there are different aspects in which I have to consider to make my actions. Okay, so this is on a very rough overview of how an autonomous vehicle is designed. This is on the project of the data sets that are existing. People who are interested can start working on the autonomous vehicle. There are a lot of data sets. Data sets are nothing but people have captured these information using lidars, radars, video cameras, and they've given it to you so that you can start implementing it and you can design a prototype of an autonomous vehicle. Okay, so the first step in building a self-driving car, you have to collect data, model your data using machine learning, deep learning algorithm, and deploy your simple self-driving cars. Um, so how do you model it? Using ML and deep learning algorithms. So there are 2 aspects of data sets. Data set is nothing but, data set is what is your past experience. People have given that data for you. There are 2 aspects of data set. One is called perception data set. The other one is called prediction and planning data set. Perception data sets tells you about these lidars, radars, video cameras information telling about the different aspects of the environment. Okay, whereas your prediction and planning data set tells you how to perform these motion planning, finding out what are the agents around me and how are the agents, how are the other cars are going to move forward. And it also tells you some planning algorithms of what should I do so that my actions, what plan should I do, whether to apply brake and all that. Okay, those set of data sets are called as prediction and planning data sets. The whatever information you capture through the sensors are called perception data set. Okay, so this is from a very standard repository. I've just taken this diagram. Okay, so this there are 2 aspects of data and it is an open source. Okay, whatever data sets I'm listing out here are some open source data sets. Where you have some A to D2 data sets. Then there are something called Apollo Scape Open data set, Agroverse data set, Level 5. Okay, Waymo, this is a Google data set where the autonomous car could be designed. Okay, and this particular site tells you there are a lot more data sets that are available. So you can download it and you can start implementing it, or you can at least have, and you can build a very simple prototype of like how a robo moves in the environment, we can come out with a self-driving car which takes the shortest path to reach your destination. Okay, so with this introduction, I'm just going to show you, 1 minute, a site. Is my screen visible? Is the screen visible?
Yes, yes, ma'am. Yes, ma'am.
Yes. Okay. So, this is actually, and what a Python wish viewer. Okay, this is an API which the Python has given out for modeling these or visualizing the data which is available there in the autonomous driving data set. Okay. So